Thank you, everyone. Before I go to my topic, I'll just speak a little bit more about circular economy, a few points about circular economy. Basically, in a circular economy, what we anticipate is end-to-end from the product being made from the raw material stage to back to reuse. That is the complete cycle of circular economy. It includes making products from the polymer, going to the consumer uses and discards it. After discarding, it is collected. Whilst collecting, there is segregation taking place, and after segregation, it goes into um, recycling or other processes wherein it can be converted to other products whatsoever you wish to make, and so it is a closed loop system. I will now go to my topic about post-consumer plastic waste management. What I intend to do today is talk to you about what dominates the waste generation in the post-consumer market, and what are the different processes available for making products or granules and reusing the waste generated from these packaging mix. Okay. You can see now on the screen the slide which tells you the different types of packaging that are consuming the maximum plastics today. And if you see, the maximum consumed plastics are in the biscuits or the dry processed category, where 98% of plastics is used to pack the product. Similarly, then it comes to confectionery, baked products. So if you see, overall packaging is the major sector where waste is generated today. And because of that, recycling is most important. And most of this packaging, by the way, enters the landfill. And to avoid this landfill, we need to recycle it. Today, India is close to recycling around 60% of their generated waste. They are generating, these are, by the way, 2012 figures. We have generated 15,342 tons of waste, as against which we are recycling around 9,205 tons, which is around 60% of the waste that is generated. The future figures, anticipated figures of waste in to recycling would be around 3.1% CAGR, which shows a very good figure considering the overall criteria worldwide. But India should be able to achieve much more than 3.1%. There are many reasons why India can have a bigger figure, mostly because today circular economy is something which is very new. I will come to these points also again, but circular economy is very much new to the Indian recycling industry. And the most important issue today is the proper system of solid waste management and the proper you can say waste segregation system, which are not in place. None of the municipal corporations except one or two, which is Indore, Goa, are doing proper waste management systems. So that's a basic reason for the waste generation and increase. Now, if you see the overall plastic consumption, other than the packaging sector, which is around 24%, you can see houseware, agriculture, which is around 23%, houseware is around 10%, electronics is around 16%. These are the major criteria. Then there are smaller categories where you see furniture around 1%, transportation 4%. So transportation by itself is again packaging, but still we put transportation as a separate category, because if there is a machine going, it could not be packaging, it's just a wrapping. So transportation by itself is a separate category. Building construction industry is around 8%, and others would be around 14%. So you can see the breakup of the waste generation in India or the world. Now you see the Indian map here is showing you the various locations, especially the major cities of India, where waste is generated, and you will see a whooping 6.92% average plastic waste share in municipal solid waste, which comes to around 4,059.18 tons per day. That's a big quantity. India's four major metros generate more than 1,670 tons of plastic waste per day, which is around 40% of the plastic waste produced in India. India waste management market. Let's talk about particularly the Indian continent, because when we talk about the world, it's a different scenario. But when it comes to India, India is a major driving force for the growth of plastic waste management market in the Asia Pacific region. After China, India was the highest recycling country in the world. Now we see a lot of shift from China to Vietnam, Cambodia, Indonesia, and various other countries, Malaysia, Thailand for that sake, where most of the waste of the world are being dumped. India, we have banned the waste procurement, so we are not allowing imports of waste in India. So we are just recycling what is being generated in India. The Indian waste management market is witnessing a healthy growth rate owing to the high population density and increased industrial activity, which is generating high amounts of waste, both hazardous and non-hazardous. Here I will also like to add the Indian waste management market is witnessing a healthy growth also because of the varied culture wherein recycling is done in a very big way. Then, as I told earlier, circular economy concept is relatively new to India. However, the concept is gaining prominence. The Indian waste management industry offers huge potential, as only 30% of the 75% recyclable waste is being currently recycled. Shortage of proper policies for collection, disposal, and recycling. As I said again, this is the same issue. And the lack of efficient infrastructure are few of the many reasons leading to poor waste management in the country. Many startups are coming up with innovative ideas to manage waste, as well as convert them into valuable resources. However, India requires a fair amount of knowledge to tackle the challenges plaguing the recycling industry. Let me come to the definition, because there is a lot of ambiguity in the market about what is recycling, upcycling, downcycling. People talk that everything is not the same, but the definitions as per the Plastic Waste Management Rule 2006, which still remain the same after the revisions in 2018 and 2019, is that recycling means to convert waste into reusable material reuse, reprocess, reclaim, recover, convert into something, return in previous stage in a cyclic process. So even if it is used for fuel conversion or for energy conversion, it is still recycling, which people normally say it is downcycling, as we are converting it into useful products like fuel or energy. In plastics to road, we use the to reduce the tar cost. So ultimately, again, you are saving something and you improve the quality of the road. What are the different recycling techniques? According to the definition, then all of this falls under recycling. So let's talk about the different techniques of recycling. The major and the most important and the most used today is plastic waste to mechanical recycling, wherein you convert waste to granules. The next is mixed plastic waste to profile extrusion, wherein you can add fillers or you may avoid adding fillers, but you need to eliminate PVC, because PVC normally tends to create a lot of gases during the process when it's mixed with other plastics. So vinyl is the product which has to be eliminated, and as such, that would reduce the burden on the recycling sector. Plastic waste converted to fuel, plastic waste converted to energy, plastic waste added to road construction to enhance the road life, and finally plastic waste used in cement kilns, boilers, etc. As for every ton of plastic used, fossil fuel corresponding to 17 to 42 GJ can be saved. Now there is one more criteria in this also. The calorific value of plastics is very high, and the highest, I would say. And hence using this plastic waste in cement kilns helps to improve the burning and quality of cement. And the residual fly ash which is left is used in cement to enhance the quality. What are the different I would say recycling process in post-consumer waste manufacturing, waste recycling. The first and foremost is, as Mr. Pava said, segregation of plastics from other waste. Here, I wouldn't suggest to use segregation techniques like in infrared sensors, or because other wastes are, maybe not able to take charge or current or those sort of techniques. So here, segregation would be either a manual process or using trommels or technologies like that. Segregation at source also is an important factor, which most of the municipal corporations should enforce in the coming days, if you really want to do proper recycling. Then comes sorting of mixed plastics, where you need to sort it by polymer. This is done only to remove the highest quantum of polymers. For example, if you go to post-consumer waste market, today you will find maximum plastic that is there in it is polyethylene, which could be LDP, HM, LLDP, and polypropylene. So sorting is very important, and here you need the infrared sorting systems. Then you need the shredding or cutting of the waste that comes in. You need to shred it to make it to smaller sizes so that the process of washing and recycling is easier. Here the shredding is an important factor, wherein you need to actually make it to not very small size, but to a reasonably small size to wash it in a proper way. Then you come to the dry or wet washing system, wherein you use centrifugal washing systems for dry washing, or wet washing can be done again through a centrifugal or a high speed, um, sort of a high speed mixer sort of a thing, wherein you add the detergent and water and you can get your recycling done. Then, oops. Then comes the drying centrifugal or the hot conveying. Now, the drying, where you have the centrifugal or the hot conveying system, is important because you need to remove the moisture to up to 98% to be able to recycle it using recycling machines. This particular stage, the grinding, agglomeration, and densification, is an optional system. It depends on the size of your article after the drying stage. So if the size is quite big, you need to grind it. Agglomeration and densification is a online system wherein you can have a densifier on the recycling machine. So it makes life easier. You don't need to grind it to very small particle sizes. Only the shredded material can be directly put into densifiers and recycled. Then comes the recycling machine, or the repalletizing, reclaiming, or the recycling part. Let me make things a little bit more clear here. Repalletizing, reclaiming, or recycling, here we mean is not only making granules. Here you can even consider making profiles or any other product, like in PET industry they make fiber or yarn or filaments out of it. That is also called as recycling technology. So in mixed plastic waste, for example, we suggest a technology to make profiles which can be used for various applications. Applications will be following. Okay. Now let me come to the washing system, wherein the complete utility or requirement of the equipment would be starting from shredder grinder, which I said to reduce the particle size to a reasonably washable size. Prior to this, as I said, you need to remove the waste, other waste which are non-plastics, and also segregate the waste which is recyclable into granules. This now we are talking about is the waste which is recyclable but used for manufacturing profiles or similar products. So after the shredding and grinding, we go to the friction washing, then we go to the flotation tank. The friction washing, we are able to remove 95% of the dirt stuck on the plastic waste which is there. 5% will be in the subsequent processes. So around 100% can be achieved in a fully automatic washing system. Then comes the drying centrifuge, the flotation tank, where heavy particles like sand, stones, metal, etc. can be removed. Then comes the drying centrifuge, where you can really dry the material to around 90-92%, starting from 85 to 92% dry material, depending on the length of the friction dryer or the type of waste that is there. And then you are passing it through the hot air dryer, where you are able to dry it to the 100%. People are still entering the arena. I'm surprised. Okay, then we come to the recycling. Just give me a second. Okay, I am back. Okay, recycling and pelletizing, this is for making granules. Let me be clear that here, if the plastic waste is mixed, we would recommend that plastic waste is mixed, we would recommend that this could be used only if you have technologies in place to uh, uh, make a product out of it. Um, so the complete system is including densifiers, cutter compactors. Now the tall tank you are seeing are either a densifier or a cutter compactor or a force feeder. Now I'll tell you the difference between the three. Densifier is sort of a semi-agglomeration system. Cutter compactor is similar to an agglomerator, and force feeding system is a system where you need a pre-grinder. You can grind the waste and you can feed it through the force feeding system to the extrusion portion. Then we have the vented extruder, where during the process, during the melting process, you are able to remove a lot of contaminants like moistures, you have burnt printing inks or some burnt contaminants like paper, etc., which would be burnt during the processing, could be eliminated because of the gas generation during the process. You can also remove a lot of gases like in the expanded materials like polystyrene, foam based material. You are able to remove the gases. Then we come to the screen changer, where depending on the filter size, the filter mesh size, I would be precise, because the diameter is dependent on the screw diameter of the machine. Diameter of the filter is dependent on the screw diameter of the machine, but the mesh of the filter determines the amount of filtration you want to do. Then we can pass it through the die-phase cutter or strand pelletizer, or there are these two major techniques today where you can make granules out of it. Then we have the system for mixed plastic waste to profiles, which I have been talking about since the beginning. Now this technology is very, very, very good for multi-layered plastics, and could be helpful to make products directly instead of making granules and then making profiles or products which using an injection molding technology. This is a very new development. So you are seeing the prototype machine there in the photograph, which is very crude, but the equipments that we have already delivered to our major two clients, I will give you all the name. One is Longinotti and the other is Revet. Both are in Italy. The equipments are made in India and delivered to them, and they are manufacturing profiles out of these equipment. Now, this, as I said, the photograph is a prototype, so you may not be able to see the right um, 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 or the right quality which the GMS is able to supply, but it is an idea. So this machine can again be built. Well, I would say this machine is similar to the recycling technology, except instead of putting a screen changer and then a die phase cutter, you have the die head which would be feeding the waste directly into the profile die. So there is a die head with multi-port in extrusion with a fluidization valve, so that you can control which port will be injecting the material at that particular time. The molds could be automized or could be even manually filled, manually fixed to the machine, depending on the investment that a person would like to do. The molds are then filled with the similar to an injection molding technology, and then the product with the mold is taken to a cooling tank and then extruded using a profile remover. This is a typical example of a mold. Now here you see this long mold is of a profile which is for supports of, you know, um, um, uh, a good looking garden area. I have some photographs in the subsequent slides which will show you the application where this particular profile was. Or you can see these profiles where you can, where construction based products are made. Now, these molds can be filled depending on the capacity, but the main important thing about these molds are during the filling, there are a lot of air inside the material and air inside, or the gases generated inside the material which keep on extruding with the material. So you need to continuously exhaust that material. So the mold design is very, very critical, wherein you need to inject the material and try to push it enough that it is completely full without being hollow. Now you see the different profiles that can be made. The one in the center here, this one is the long profile where you can make different products, or you can use it for housing purpose, housing the construction purpose. Then this with the four holes on the top. This is a brick actually. You can see it in the subsequent slide, or in this slide you can see it here in the retaining wall in the lake or the rivers, or in the compound of the any compound of the land. This is the profile I was talking about, the long one where the mold was used, the long mold was used to fill. There would be slight warpage. If you see here, there is a bend. This depends on the cooling time you give to the mold. The longer the cooling time, the lesser the warpage. The more the cooling, the lesser the cooling time, there is more the warpage. Okay. Here comes the different applications. Now you see these are the row houses which are made completely from plastic except the base profile which you see here, which is of metal. This is just to create enough support to the complete houses. Now, these full row houses, right from bricks to the supports, to the doors, to the roof, windows, except the glass, is completely made of waste plastics. There is nothing which is other than plastics. The benches are completely made of plastic waste. The pallets which are used for packing and shipping material are completely made from plastics. Sorry. The benches here are completely made from plastics. These are the separation pillars between the main road and the footpath, which are made completely of plastics. Now this can be also kept with lights inside. You see these are lighted. So various applications can be developed. You have to have the idea what you want to really do. Let me come to the houses. This is a complete project in Africa, which is done by our customer Revet, which is in Italy. And you see here, they are actually building up the houses inside the plant to set up the size which they want according to the location which has been provided. After this, they cut the other profiles according to this size and then prepare the houses which are shipped. And then on site, you need minimum tools. You just need probably a hammer, a spanner, a ladder, or few things to complete the project. Now you see the bricks are also, as I showed you earlier, are also of plastic. The pillars are of plastic. The walls are plastic. The top beams are of plastic. The windows are plastic. The doors are plastic. Everything here is completely built with plastic. These are earthquake proof and all weather proof houses. Then you may come up with a question that being plastic, won't heat be creating a problem? When you talk about mixed plastics normally have a lot of content of different polymers, which would be making the final waste a very high temperature material. So the processing, and especially when you talk of mixed plastic, there would be nylon, there would be polyester, which are high temperature material. So when you have such high temperature materials, if your ambient temperature is 60 degrees also, there wouldn't be any issue with the walls or houses. What are the important requirements? The most important things that you need to take care while recycling mixed plastic waste is to avoid any type of vinyl waste into the mix. As I said earlier, grinding is required prior to cleaning. You need to grind the waste before cleaning. Ferrous metal and other metals have to be removed using various systems. Systems would be like a belt conveyor with a metal detector, or a pipe uh, fluidization valve, wherein with a deviator valve, I would say, wherein the waste can be deviated if with metal content in another direction. So you need to put a metal detection system. Dirt has to be dried and then dusted. So you need to actually dry the waste and then dust it. So you need to remove the dust using uh, okay, you need to dust using a centrifugal dusting unit or alike. Then you need the extrusion system must be a big diameter one. So the extruder has to create a lot of gases during the extrusion system so that the gases can be removed maximum using venting systems to get minimum gas left in the waste. This is our link where you can see the video. I leave it on for a few minutes if you want to make a note. Of course, this presentation will be mailed to each of you. If you really want it, you can even write to us. Our mail IDs will also follow. You already have our mail ID also. You can write to us anytime. Um, I would at this point like to add a few things about our team. We have two sales people who are already on this at the moment, on this chat at the moment. One is Mr. Vasu Agela, who's handling the west and north zone, and then there is Mr. Anand Pandey, who is handling the south and the east zone. So if anyone has any queries or anything, you can contact us anytime. The contact details are here below. You have the email ID and the mobile number where you can leave a message. You can WhatsApp us on this number, and immediately our team will be in touch with you. Thank you.